Hi everyone and welcome. In this video, we are going to see how we do hyperparameter tuning using GridSearch and RandomizedSearch. So here I have imported all the packages and I have this data set of titanium. So here we have done all the pre-processing tasks, and here I am doing a X and Y. So in X we have the all the dependent features, and in Y we have the dependent feature here. Then we have done a train test split, and here we have given test size equals to 0.2. So in our training data we have 80% of our data, and in testing we have 20%. And here if you check the shape, comes out to be in training data we have 712 records, and in testing data we have 179 records. Now I'm going to build a decision tree classifier here. So here I have built a decision tree classifier, and also I'm doing this prediction for training as well as testing. So here I'm checking this accuracy score for my training set. So here for training set the accuracy score is 0.98, and for testing it is 0.78. So if you see, there is a big difference in the training accuracy and testing accuracy, right? So here you can perform this cross validation and check this. So here I have done this cross validation. We have passed this decision tree and we are doing 10-fold cross validation here. So here after doing 10-fold of cross validation, we are getting this accuracy of 0.77. Alright, now the next step will be decide this parameters here, right? How can we choose this optimal value of all these parameters in decision tree? So there are many parameters, right? So here I have written this code just for finding this optimal value for maximum depth here. Alright, and we are checking this training accuracy and testing accuracy. Alright, so we are doing prediction and storing that after each iteration of this for loop. So here we are running this for loop, and it takes the value from 1 to 19. So here we have given 1 to 20 as the highest value, or the last value is excluded here. So it will run for 1 to 90. So at first run, going to take the max depth here. The max depth is going to be 1. Then we are building this decision tree. So we are fitting our data. Then we are doing this prediction and checking our accuracy scores and appending this into training predict and testing predict. Now what we can do is we can check for how well our model is working with this different depth, right? So here I have plotted this graph, and you can see that as the depth of the tree increases, there is a big difference between your training accuracy and testing accuracy. So at depth 3 you have this training accuracy and testing accuracy between 80 to 85, and they are closer, right? Now like this you have different parameters, right? So here we have done this only for maximum depth. Now you have criterion, you can give either Gini or entropy, and you also have different parameters. So here if you see, I have all these parameters like maximum depth, criteria, minimum sample split, minimum sample slip, and all those hyperparameters. So we are going to see how we can do that using this randomized search CV. So here perform this cross validation by taking maximum depth after observing from this graph. So you have taken this maximum depth equals to 3, then you are again doing this cross validation. So 10-fold cross validation here, and this time with maximum depth of 3 you are getting this 0.81 cross validation score here. Now let's see how we can find this optimal value of all these parameters using GridSearch CV. So here I have given this. So we are importing this package. So from sklearn.model selection we are importing GridSearch CV here. Alright, and here DD tree equals to our decision tree classifier, and here we have given this parameter grid. So here if you see, we have criterion, Gini or entropy. So it is going to try out with these two criterions and all the different combination of maximum depth, minimum sample lift, minimum sample split. So here this maximum depth is going to take from 1 to 15. So here, and your minimum sample lift is going to be between 2 to 5, and same is for minimum samples split. Now also you don't have to perform this cross validation by writing another line of code. You can perform that in the same line here. So here we have given grid search equals to grid search CV, our D tree, so it is going to be DD tree, then param grid equals to your param grid. So here it is going to take all of this param or parameters and going to see all these parameters, all this combination of these parameters, and it is going to return you the optimal parameters for this criterion, maximum depth, minimum samples depth and minimum samples split. And also you want to perform the 10-fold cross validation here. Alright, now let's run this. So again you have to fit your data. So here we are writing, and also we are going to measure the time. So how much time does it take to find all these hyperparameters or optimal hyperparameters for your decision tree? So let's run this, and here I have given G grid, that is our grid search CV with D tree estimator and all these parameter distribution of this parameter, and it will also perform 10-fold cross validation. So I have given grid.fit x and y, and we are also measuring the time. How much time does it take to find this all hyperparameters? Let's run this. It is going to take some time, and after it runs successfully, see the time taken to find this optimal parameter. So here time taken is 12.82 seconds. Alright, and now to check your best parameters or optimal parameters, you can write grid dot best underscore params, and this will give you the optimal value of this parameter. So here the criterion is Gini, maximum depth is 10, minimum samples lift is 3, and minimum sample split is 4 here. So these are your optimal hyperparameter using grid search. Now if you want to check what is the best score that you are getting, you can write grid dot best underscore score underscore. So let's run this, and here if you see, for best cross validation score you are getting is 0.82. Alright, now that you have learned about this grid search, let's see how we can perform this hyperparameter tuning using randomized search and find this optimal parameters. So here have to import this randomized search CV from sklearn module. From sklearn.model selection, import randomized search CV, and again we are going to take the same parameter distribution that we have taken here. So here it is going to be param grid and all of these parameters values that we have assigned. Alright, now here we have given this rand search equals to randomized search CV, and this here is going to be GD tree, and your parameter distribution equals to your param grid, and here there is one more parameter or argument that we are giving. It is n iter equals to 10. So it is not going to check for all of this combination of hyperparameters or the values that you have given for all these parameters. Rather, what it will do is it will look for this 10 random hyperparameters, combination of these parameters, and give you this optimal value of this parameters from all of this 10 randomly chosen combination of parameters. And also we are performing this cross validation, that is 10-fold cross validation here. So let's run this, and in next cell what we are doing is we are running this, fitting our x and y, and we are performing this randomized search CV, and also we are checking for the time it takes here. Let's run this, and here if you see, you have got this result in 0.54 seconds, which is way faster than your grid search, right? But there is a chance that you might not find the optimal value of your hyperparameter, but this is faster than grid search. Now in order to check the best score, you can give this rand search dot best underscore score underscore. Let's run this, and to check your best parameters, you can give this rand search dot best underscore params underscore, and if you run this, you have this optimal value of this parameters. And if you see here, you have got a different value for all of these parameters. So here max depth was 10 when you did grid search, but in randomized search you are getting 7, as it is just randomly choosing this combination of parameters. Alright, now you can also take this best estimators. So here best estimator is entropy, right? Criterion equals to entropy, and maximum depth is 7. So this is your decision tree with the best estimators or your best hyperparameters. So I hope it is clear to you now, and now you can perform this hyperparameter tuning for your models.